Okay, so now we're going to go over how all of this connects to the lab. Everything in part one you're going to do in lab lecture, then you can get to the next part where we're going to begin doing stuff in lab. So in this first part, we're going to be collecting these colors and wavelengths experimentally. So I'm just going to type in a bunch of nonsense that is definitely not what you're going to see in lab. I just don't want to give answers to anybody because everybody might get different answers. So we're just going to call it colors 1, 2, 3, and 4 and give them random wavelengths that will just make easy numbers. So then once you type all of that in, you are going to see a table that looks like this, where it shows you all the colors and their corresponding wavelengths. And then we're going to come down here and we're going to start doing the calculations. So the first calculation is to take one of your wavelengths and we're going to convert it from nanometers into meters. And we're going to use our coding knowledge to do that. So the directions will be very explicit in the lab, but we're going to be doing this first part together. So let's take the first one, for example. So we're just going to take color 1, which I have at 400. And here we have our conversion where 1 nanometer is 10 to the negative 9 meters. So we're going to be using that fact where if we multiply by 10 to the negative 9, we get our answer. So let's start coding. Okay, so let's begin to code this. So we're going to start with a wavelength. And like I mentioned, we can just use 400. So we're making a variable, we're setting it equal to 400, and we'll give you specific instructions on what to name these functions. But next we're going to make a function. So remember, we start with def, and now we're going to name the function. This one we're going to call unit conversion. And the computer wants to do it for me, but we're going to do a little bit different. So I'm going to call the parameter wavelength in nanometers, because we're going from nanometers to meters. And I just wanted to name it something different so you didn't get confused with the variable that we just made. So now, remember the calculation that 1 nanometer is 10 to the negative 9 meters. So we're going to return the parameter wavelength in nanometers, and we're going to multiply it by 10 to the negative 9. And remember, to do exponents, you have to do the double star. And I was just putting that in parentheses just to get the order of operations correct. So now we're going to want to call this function and pass in 400 to the wavelength nanometers parameter. And then it's going to return 400 times 10 to the negative 9, which will give us our answer in meters. But you don't have to call in this function. So the way that this lab is going to work is that you're just creating the function and the next block of code is going to test it for you. So this is complete. That is a complete correct answer that I have typed in right now. And you can run it just to make sure there's no compilation errors. And then the next block of code is provided for you where it's going to test the answer. So if we run this, we get a green check, and now let's test it. And you can see in the terminal down below that it gives us a calculated value, print it out, and it tells us that we're correct. Okay, so now we're going to do the very last thing that you need to know to complete this lab. So as of right now, we've talked about how you're going to do part 1 in lab lecture, and to start part 2, you're going to collect the wavelengths and colors experimentally. You're going to fill in the table, and then we're going to start here with this first calculation. And now all of the calculation portions in this lab will be exactly the same. It'll just be you creating a function that does a calculation that we want, and then you're going to check it with the next block and you can move on. So the way that we're going to move between calculations is we're going to take the answer that we got from the previous one. So if we go down here, this is the answer that I got when I did the work for the first one. So we're going to copy that, and we're going to go to the next calculation, and we're going to paste it in where it says lambda meter equals blank. So we're leaving that blank because people might have different answers. And then we're going to paste our answer in there from the first one because we know it's correct. We ran the check block code and it says we're correct. So we're pasting it in there, and now from there we can do the same thing where we're going to define a function, we're going to name it something, and again, we'll tell you what to name it. We're going to have a parameter and a return statement, and you're basically just going to do that same process for the whole lab.